So while we come back to this same slide that we were looking at the end of previous video, you see the cluster number 3 has actually these genes that are very likely to be a longevity genes. Similar things happening in cluster number 8. You can see that there are 4 genes being in the same cluster, while this gene is regular not identified genes compared with all other 3 non-longevity genes. So that you can see this is a cluster that also highly suggests that this is going to be a longevity genes. And through this research, I want you guys to see that how do we use clustering to do some data mining research. This is purely the methods that we try to group similar things together. The label, which indicating whether or not they are longevity genes, are not included in the clustering process. We only use those labels after the clusters are formed. So it gives you a good understanding of how clustering can be used in many different things. So in this case, we actually looked into that. You can see this is cluster number 3. It has a very high percentage based on our clustering analysis being grouped into non-longevity genes clusters. And the similar things about this one, this is another examples that we have seen in the previous slide. And therefore, we are able to generate a table listed out what are the genes that are likely to be longevity genes. In this case, we use color. The red color means they are highly possible to be the longevity genes. The orange one are likely, and the yellow one are possibly longevity genes. And of course, I want you guys to understand that we use the number of iterations equal to 40 because we are able to generate the highest amount of clusters. At the same time, if we change that iteration, the result, the table results we will see is going to be slightly changed. So that in actually the thesis that I want you guys to read have many different kind of experiments, including different data set of the micro array information, as well as different number of iterations being applied. In the conclusion of this result, we actually finding out that these 6 genes, based on our experiments, are very likely to be longevity genes. And in fact, this paper were published in 2013, and while I joined another conference in 2015, out of these 6 genes, 2 of them in 2 years are being identified as real longevity genes. Therefore, I do think that we have achieved something that are very interesting and be able to help biologists to carry out their experiments. So that is about the research related to hierarchical clustering. Now, I want to continue with talking another interesting clustering algorithms that combines the hierarchical clustering as well as the k-means clustering. And in fact, I'm the one who developed this clustering algorithm. So let's take a look at what is about this algorithm. The motivation is this one. Among all clustering algorithms, hierarchical clustering and k-means clustering are the 2 most popular clustering algorithms. However, both of them have some disadvantages. For k-means clustering, you need to know how many number of k, as well as you need to have some method to generate the initial centroid. So it's actually hard to start the k-means clustering. While hierarchical clustering is pretty easy to start because all you need to do is merge until everything become a big cluster. The difficult of the hierarchical clustering is that after the tree is built, where do you cut and generate the real clusters is actually a difficult problem. And the idea is this. Since the k-means clustering is having difficulty to start. And hierarchical clustering have difficulties in the end. And the idea is this: why don't we use hierarchical clustering for the first half roughly, and then continue by the k-means clustering, so that hierarchical clustering don't need to be cut, and using the results generated from hierarchical clustering can actually provide starting points for k-means clustering, including the number of clusters as well as the location of the center. So it's pretty interesting. And therefore, what we have trying to do is this. We actually, first of all, need to finish the hierarchical clustering first, and then keep track of how many number of clusters are generated. Just like what we did in the earlier slides, like this one. We keep track of this figure, understanding how many number of clusters are being generated. So we need to finish one round of hierarchical clustering. And then, just like this experiment, we then let it stop, okay? We are most likely interested in the point that gives us the highest number of clusters. So in this example, we want it to stop at the hierarchical clustering of iteration number 40. You may ask, this 30 may also give you the same amount of cluster. So it's actually another good choice as well. So it depends on how you want to choose if there is a tie. So basically, come back to the pseudocode. We first of all run the hierarchical clustering and then keep track of number of clusters. And then we run the same thing again. And let it stop when the largest number of clusters is generated. So once we found that, we actually have the number of clusters. And for each cluster, they also have their centers already. So basically, we have the number of clusters, and we also know where do we start the cluster. And at that stage, we keep all the clusters intact, which means that the cluster being clustered together, we cluster them together because that's coming from hierarchical clustering. So we don't want to change those points that are already clusters. However, at the same time, for those points that are not clustered yet, we will use k-means clustering to assign them to the closest points and then recalculate the center until there is no change. So let's take a look of an example. By looking into this one, it's the same thing that we have seen. So originally we have 8 points over here, starting with x6 and x7 being clustered together. The next thing is x2 and x3, then x4 and x5, and then you will want to cluster these two clusters together, and basically we will continue on the process. The next one is combine x1 with this cluster, and then have this huge cluster, and finally we have all of the things being clustered together. So you can see that we still operate the whole hierarchical clustering once, 6 and 7. So at this stage, we have one cluster. At this stage, we have 2 clusters. And then next step, we have 3 clusters. And then we have 2. So you can see that because these 2 are being merged together. So I have 1 cluster here, 1 cluster here. And we will have 2 clusters at this stage. We have another 2 clusters at this stage. And then we will have 1 cluster at this stage. Therefore, you can see that if we try to keep track of the number of clusters in a figure, you can see it will goes up and it will goes down. In the hierarchical k-means clustering, the hybrid version, what we are interested in is the one that gives you the highest amount of cluster. So we will need to run the hierarchical clusters one more time. It will come join 2 points, join another 2 points, join another 2 points. At that stage, it forms 3 clusters, and we will stop at this stage. So you will see that when we comes to the figures, those 3 clusters are being clustered together already. There's only 2 clusters that have not been assigned. So at this stage, we will use this one, and this one, which indicating for k-means clustering we are about to implement, k equal to 3. The centroid would be the centroid of the 3 clusters. So for the next thing is that x1 will calculate the distance between this one, and that one, and then assign to the closest one. For x8, it will do the same thing, calculate the distance among the 3, and then it will assign to the closer one. So you can see that we will be able to use the operation of the k-means clustering to help us find the clusters. We will repeat this process until there is no change. So this is the idea about the hybrid hierarchical k-means clustering. Like I said, in order to make sure all of you guys have participated in the video watching, and to be honest with you, because I can see how many times the video has been watched. I noticed that probably all of you watched the first video on Tuesday's class, but some of you did not watch the second video. In this case, I want to assign some assignments for you guys to do. So in the end of the videos, I want you guys to pull out pen and paper or whatever things that you have done, and then work on some problem. So for this class, the questions I'm going to assign to you guys is this one. This is the data set that are used for many times. We use this one in k-means clustering. We use this one in the hierarchical clustering. So I want you guys to do this. Use this data set. It has about 15 data points. I want you guys to apply the idea of hybrid hierarchical k-means clustering, which means that you need to apply the full hierarchical clustering first, and then find out the points that the time that give you the highest number of the cluster, and then use that information to continue with the k-means clustering. So I want you to do that part. And then all I want you to report to me is that create a document. First of all, tell me how many number of clusters are generated. And then, and if there's a tie or anything, give me some descriptions. And after that, I want you to finish the hybrid hierarchical k-means clustering, and then tell me how many clusters has been generated and what are the members in each cluster. So I want you to create a Word document to keep track of this information, submit that to Blackboard as an assignment so that I would be able to know whether or not you have fully participated on the class, as well as how much you have understand about this material. So that is what I want you guys to do. Okay, and like I mentioned in the previous video, on Tuesday and Thursday, from the time of 10:50 until 12:05, I will open a Google Meet meeting for you guys to join and ask questions. So you can still watch the videos. I want you guys to ask the questions. And after the spring break, depends on how I have decided. Maybe we will keep doing the same thing. Let you guys watch the video and I can open up a time for you guys to ask questions. Or maybe I will try to deliver the class through the Google Meet, which means that at that time you will come into the Google Meet and then watch me or interact with me to have a virtual class. If you cannot do that and I choose to do that, I will record the videos for people to watch as well, so that there are many things are not decided yet. Based on the unwanted situation, things can be very interesting. That will be all for the class. Remember to submit